Okay, hello everyone. Welcome to my talk about hooking into object properties. I'm Bary, and I'm a technical manager at the Fed Guild. I worked as a software engineer in several domains. In the recent years, I was focused mostly on web applications. And my background about this talk and basically most of the stuff that I think that I really like is writing third-party scripts on a lot of vendors, Fortune 500. I also have some code in Wix login page before I came Wix. And I like beers, music, and snowboarding. So, some motivation. All of us, we're using JavaScript every day, like every normal, like except weekends, I hope. And there's a lot of internal stuff which are not too complex, but if you will be aware of them, understanding code and flows will be very easy for you. And I would like to show you some ways to do some cool stuff in JavaScript that will give you some more tools to do stuff. So let's start with what is JavaScript object. JavaScript object is a set of key value pairs, and object has its own properties, and it inherits properties from prototype. So about prototype properties, for example, if I have some object with a property has a property, it's the same property as the prototype of the object, except objects that are created with empty prototype, which doesn't have any properties. About operations that we can do on properties, basically it's like setting them, get the value of them, check if they exist, and delete them. These are the common usage of properties of JavaScript. And there's something very nice, which is called a property descriptor, which is basically an object that defines the attributes of a property. What does it mean? It means that there are access descriptors. Access descriptors are actually ways that can change the way JavaScript treats a property when some other code try to get it or to set it. And there are data descriptors, which are value, which is the direct value of a property, writable, which is the configuration of whether I can rewrite a property, enumerable, and configurable. We will see examples of all these descriptors in a few slides. So the API for changing those attributes is define property. This is the basic API for doing it, and it actually gets an object, a property to define, and a descriptor object. So on the other hand, there is get on descriptor, which means that this function returns the original descriptor of a property, and you will see how you can do it and why it's important. So some examples. For instance, if I have an object, I can use define property with a value x, and when I try to get the value, I will get the definition here. About writable, if I set writable false, so if I try to rewrite the object.x, I will get the original value. So I will actually block the property for being overridden. Enumerable is very nice attribute that I can actually hide some iterable properties inside object. So if I set some property, let's say x, of this object, and I set it as enumerable false, when, for example, I try to stringify it, I won't see it. Why? Because under the hood, I said this attribute is not enumerable on iterable operations. About set and get. The difference between get and a value is that get allows me to do extra code if I want to calculate anything. So if I want to just define a property, and if I want to add some logic when some code tries to get it, I can do it like this. And if I try to reach to x, I will see getting the value of x, and this is the exact code that I have here. So every time any code we try to go to object.x, it will be called. Same for set. If I try to set the same property, I will get to this callback. Configurable is the way that I can set the whether is the property can be overridden with an attribute, with an extra attribute or not. And again, if I try to reconfigure something that is not configurable, I will get an error. About get own property descriptor. The reason that it's very important in understanding this whole talk is that when I'm overriding something, I need to get the origin function that I overridden. Like, if I want to override some object property, again, if I want to override x, I need to get the original descriptor of the value. So what I'm doing here is actually I'm defining an object property, x, and the descriptor has a value. And when I'm setting the value, what I'm doing is I'm getting the original value of the property, and I will see, this is a bug, by the way. We should have seen a trap something. Okay, about this code, for example, like it doesn't make any sense since I'm also setting a value and a get callback. So when we define properties, we need to distinguish between access descriptors and data descriptors, and we can choose one of them. So this code will throw an error because first it's not deterministic, and I need to choose what is the right way to do the override. And basically the right way is, like the thumb rule is, if you have a direct value that you want to set, just set a value, and if you need to calculate something, set a get callback. Blocking APIs, like we discussed a bit about descriptors, how we can override them, and there's APIs that allows blocking changes of properties of objects. So there is a function called prevent extensions, which actually blocks new properties to be added to any object, and it prevents prototype reassign. Why it's so important? Because once I run object prevent extension of on any object, no code is able to change it. Like, it's very important when, let's say you have an object that you got from some response, and you pass it to your codes, and a lot of people tend to do like clone to the data and just send it to some functions, but you can just prevent extensions and block any change of the object. Another functionality is seal. Seal is like prevent extensions, but it's also set all the properties to be non-configurable. And the strongest API is freeze, which is both like it's inheriting seal and prevent extensions functionalities, and it's also set the whole, it's also a bug, it should be writable. Like, extension properties will be non-writable. So actually freeze the whole object. Like, no prototype changes, no reassigns, no writable, and nothing can be reconfigured. And it's important, I will show it in the last slides, actually, why it's so important. Some example, if I set a seal on some object, and I try to define it, I will get an error. Again, for freeze is very strong, but it has some limits because all these functionalities are working on the first layer of the properties. And if I have an object that has another object, so if I freeze O, for example, I will still be able to configure Y. So this is something that is very important to remember. Seal doesn't lock all the object, it's just locking one level of it. Okay, so we can progress to two new, relatively new, no, it's not new, like 8 years new APIs, Reflect and Proxy. Both Reflect and Proxy came with ECMAScript 6. And the Reflect is not new to software engineering because there's reflection interfaces in a lot of languages, but it's new to JavaScript and it allowed a lot of operations. Like, according to ECMAScript definition, which is very weird, the reflect object is the intrinsic object and the initial value of the reflect property of the global object. The reflect object is an ordinary object. So it doesn't make any sense, but to cut long story short, it allows to perform atomic operations on objects. And it has an interface that allows to do a lot of operations on objects. And it's very similar to what we've seen with defined property. Like with Reflect, I have static methods that allows me to do operations on objects. Let's say defined property, as we saw, is object defined property, which works the same. But here, the Reflect allows a more clean interface to overloading and changing properties of objects. Same for, let's say I want to use own keys, and if I'm using own keys on something, I just perform an action on an object. And we have proxy. Proxy and Reflect has quite the same API. It's basically the same API, the same interface, but they're both very different. Reflect allows to do operations on objects, and proxy is actually proxy to an object. What does it mean? It means that once I use proxy, for example, on this one, if I have an object and I'm creating a proxy from this object, it's kind of a trap to any access to any property, because first, it's much more stronger than just defining a certain property by defined property that I need to know the name of the property. Like here I don't need to know anything. And what I'm doing here is actually I'm adding a proxy to an object, and I can do pretty much anything. And again, it's important for further examples. Again, proxy and Reflect can work together, and again, they're not the same. Okay, another cool API that JavaScript has is scope overriding. So this with statement allows to extend existing scope. What does it mean? It means that if I write with some object, the next statement that will be executed after the with will have the scope of X. So if I'm doing this, I'm just getting more stuff to my scope. But you need to remember that it's deprecated. But again, it's being used in a lot of places today, and it will be replaced with some proposals that we will see in the further slides. So we're moving to monkey patching. Monkey patching is actually the definition of changing code. It's like meta programming, which means changing code in runtime. The basic flow of monkey patching is a code that tries to get to some API, and the patch doing something in the middle, and it sends the operation to the original API. This is like the most basic flow of patching, and there are some use cases for it, some legit, some are not. For example, Mobix is a very classic way to patching because on any change of a property or state in React, Vue, or whatever, the magic behind it is like trapping changes of properties, which for the UI framework are called state. There are some monitoring tools that also do the same, and there's two sides that also doing it. On one hand, there is malware, like malware that tries to get data from users, and client-side security scripts that actually try to block malware from doing stuff. So it's like a race condition between these two. And let's see some code examples. Okay. So let's say I have this regex expression that I want to know whether I want to trap any access to any regex in my code. So what I can do is, if I run this function, what I will do here is I'm going to override the exec property of a prototype. And it's important. Why? Because once I'm overriding a prototype property, it's actually inherited by any instance of this object. So I'm of the prototype. So if I'm doing this, I will the test will be hooked here. And by the way, this line is a fix that I needed to do for code mirror. It's not related to the flow, but once I will run it, we will see it's a trap and true, because XXX is returning this. And if I want to ruin some web application, I can just add, I can return null, and I will get, wait. Yeah. Thanks. And then I will get false. So I can hack regex, I can do a lot of stuff, and it's a very basic technique, but this technique is being used to actually catch bad scripts, because a lot of bad scripts are doing a lot of obfuscation, and in order to, like, obfuscation is a method of like hiding code with some mumble-jumble text, and the common way to get a real code is by doing some tests on regex, on strings, and this is a very common way. So it looks very simple, very naive, but it's a very strong method that a lot of places are using. Another approach is if I want to hook to any request from from the context of my page. So if I want to hook to anything, all I can do is, again, very similar to the regex example, I can just hook to the prototype response text, for example, and I can, once I return the value for this request, I will console log it's a trap. So what I did here is actually I call this HTTP request. I did a console log here, but before, but once I tried the code tried to get to the actual data, I got the hook here and I actually did the trap. And I could do anything. I could steal data, I could manipulate it, or anything. And there's another way to get data from these techniques. And for example, I have some input. Like an input could be a credit card or anything. And let's say I'm a script that I want to do. I want to change stuff, I want to steal stuff. So what I can do is actually, again, hook to the actual prototype of the input element. and I will get it by a hook to the value property of the input element here. And once any code will try to get the value, I will get the function here. So again, I will do the patch code, and I will get the patch callback, and I will get the value. So again, I could do anything here. And again, this technique is also being used to catch malware that try to get data from input elements. So again, it's very easy code, like those. It's not like it's not too complex to understand, but these are real-life examples that people are using to do bad stuff. And about scope patching, we talked a bit about scope and a bit about proxy, and I told you that both of them can be combined. So what I'm doing here is I'm using the with statement, and I'm actually overloading the scope, the global scope that I'm using with window document something, and I'm sending a proxy to it. So it means that the code here that will be executed, every access to window document will go to my code. So I'm doing here like it's a trap for a prop something, and in this code, I'm going to window document query selector body, and I'm just console log the tag name, and once I run it, I will get it's a trap prop query selector. So also window document can be overloaded, and it's another approach of changing and mutating properties. Okay. So it's look cool, it looks very strong, but monkey patching has a lot of tricky parts. The first part is the application side. Bad patching can break applications. Like if some code is patching a very sensitive object and you're doing it in a wrong way, it will break the application. You can find a lot of Slack history about tries in Business Manager, for example. And real bugs, real implementation bugs are actually propagating to the hooked functionality. What does it mean? It means that if some code is hooking a very native API and some application has a bug, the first stack trace script that it will see, it will be the hook functionality. So the first one to be blamed is the hook functionality. And there's another side of it is that there's no easy way to distinguish between between the errors of the application and the hook, and there is a race condition. It means that the first code that runs the patching mechanism will be the first one to get the native API. And so in a matter of trying to be the first, a lot of scripts tries a lot of techniques to hide each other or to block each other, and it's another part of patching in the client side. And performance, like eventually, if the patching is done for good intentions, it still have a performance impact. Like bad code doesn't care about performance. And what next? So for knowing what next, we need to understand a bit about what is JavaScript realm. JavaScript realm basically is the runtime of JavaScript. It is an isolated JavaScript context that has a global object. It's like this or self or anything. Window, not this, sorry. And intrinsic object, which are the native object of JavaScript. What it doesn't exist Web API, such as a fetch, document, and every object that's related to the web. But basically, this is the realm. It's like the context that runs the JavaScript code. And why it's very important to know it is because there are some proposals, security proposals from TC39 that are invented to actually block a lot of operations. For example, there is compartments proposal, which is in stage 1, which is actually let isolating of realms. And there is a proposal to freeze prototype. There is a proposal for shadow realm, which is like a distinct realm for some execution. For example, there is Party Town that a lot of scripts are running for security reasons, but once code will be able to be executed in a clean realm, it just can be executed on the main thread, and that's it. No need for workers and no need for anything. And there is proposal SES, which stands for Secured ECMAScript, which allows locking mechanism. These locking mechanisms, today there's some shim, which is the code that allows it, that actually using the blocking APIs to actually blocks a lot of native APIs and other code. Like the main reason of it is to not allow the external code to do some stuff on your application. And that's it. Thank you very much.